today, so pay close attention. Let me ask you some questions, just to make sure you're remembering things properly. Where does sine of an angle normally start and end? Sine. Where does it normally begin and end? 0 and 2 pi are the normal starting and ending points. What about cosine of x? Where does it normally start and end?
0.
0 and 2 pi. Okay. And yesterday we talked about tangent. Where does tangent normally begin and end? Negative pi over 2 and positive pi over 2. Those are where the asymptotes are for the tangent function. Negative pi over 2 and pi over 2. It's centered around the origin. And what about cotangent? Where are the normal asymptotes for the cotangent function? 0 and pi. Okay. So those are the important things you have to know. And if you can remember those things, then finding those values on the x or horizontal, horizontal axis become a lot easier. So that is what you have to remember. Keep them straight. So today we're graphing secant and cosecant, and I want to show you, I don't have cosecant in my calculator. So how do I type in cosecant?
1 over cosine.
Sine of x. Cosecant, is the reciprocal of our sine function. And so I want to show you how these look compared to one another. And this is our cosecant function that we're graphing today. So I want you to see what it looks like. So I'm going to graph sine of x, and then 1 over sine of x, which is cosecant. Zoom 7 for a trig graph. So here's our sine curve, middle, high, middle, low, middle. And then, oh, look at that. There's cosecant. Oh, it's like parabolas, yeah? And that's what they are, essentially. There's some vertical asymptotes in here, which those we're going to need to know. And other than that, it's just parabolas attached, an up parabola attached to a maximum, and like a down parabola shape attached to a minimum. So it's kind of nice. And so what we're doing, excuse me, what we're doing then to graph a cosecant function, we're actually just going to graph the related sine curve. And then flip out all the maxes and mins. That's all we have to do. Asymptotes and maxes and mins, and that's the graph. It's kind of nice. And so the actual graph, if I remove the sine function, this is just the cosecant graph. It's just that sort of parabola shape and asymptotes. Okay, so today we use sine and cosine as guidelines for graphing secant and cosecant. So you want to learn how to type those things into your calculators, because it's definitely something good to know how to do, and it is a little tricky. So this is it today. Example 1.
Yes.
Sketch the graph of the function, state the domain range, and asymptotes. Domain range and asymptotes. I learned first period that I need to allow myself more space for these. So don't give yourself plenty of room. I didn't. This was not enough for me today. So this is y equals the cosecant of pi x plus 1. What is this plus 1 doing? Yeah, shifting it up 1. Very good. So that's the midline. And so just making sure we remember those kinds of things. And this pi x is the stuff that's inside the function with x. So that's going to change our x-axis. It's going to change us horizontally. So in order to graph this function, we're going to change out cosecant for its reciprocal one that we already know how to graph. So we're going to graph sine of pi x plus 1. And so sine of pi x plus 1 has a midline at 1. I can do that. Has a midline at 1. And it has a maximum value of what? 2. Yeah, the amplitude is 1, so that's 1 unit above the midline and 1 unit below the midline. So I'm just going to use a dotted line for my midline. And then I need to figure out my horizontal axis here. And we do that with the normal starting and ending. So where does sine normally begin and end? 0 and 2 pi, right? So I take all that stuff on the inside with x and solve for the beginning and the end. So I'm just going to divide by divide by pi. And we get 0 equals x, which equals, cross out the pi's, 2. So this one starts at 0 and ends at 2. And that's one period of our function. I'm going to go ahead and subdivide just like we've done in the past. What is halfway between 0 and 2?
1.
1. What's halfway between 0 and 1? 1/2. And what's halfway between 1 and 2? 3 halves. Add and divide by 2. So 1 plus 2 is 3, divided by 2. 3 halves. And then we can do our little sine curve. And what was the sine song? Middle, high, middle, low, middle. Very good. Okay, so I'm just going to make it a dotted curve here because it's not really there. It's a guideline for us. Now, to actually create the cosecant curve, cosecant is the reciprocal. And so what happens at any place where we cross the midline, our sine curve equation has a total value of 0. It's like a net 0, okay? Now, if we were to take the reciprocal of that, if sine has a value of 0, cosecant would be 1 over 0, the reciprocal. And what is 1 over 0? Undefined. And so anywhere where we have a midline, anytime we cross the midline, we are going to graph our vertical asymptotes. All those midline values turn into vertical asymptotes. So, and that's sort of the rule. Anywhere you cross the midline. So the total value for the sine function here is like a net of 0 is what happens. It's kind of weird, and if cosecant is the reciprocal, then that would flip 0 and it would become 1 over 0, which is when the 0 is under, it's undefined. Anytime we get something undefined, that's where we get those vertical asymptotes from. Then all we have to do is those little parabola shapes. So here at the maximum, I'm just going to draw in an up parabola. At the minimum, a down parabola in between those asymptotes. And that's it. That's one cycle of our cosecant function. So the pink graph is the actual graph. Let's see. We could check on our calculator. So it's important to know this one's a pretty complicated one to get into your calculator. And so if I wanted to type it in my calculator, I don't have cosecant. What do I have to use for cosecant? 1 over sine. So 1 over sine of pi x. The plus 1 is just a big on the outside plus 1. I don't want to put parentheses around all of it because I don't want the 1 added to the denominators. Okay, so, whoa, I'm going to go ahead and try that and see if we're good. So 1 over the sine of pi x, and then plus 1. And it takes a little while, I think, to figure out how to type these things in. So I definitely encourage you to check, to give it a try. I'm going to make my x-axis go from 0 to 2. And my -4 to 4 for my y-axis is fine. So see what it looks like. Pretty good. Now it looks like this is touching at 0 on the x-axis, and we actually are as well. But I just drew in my midline instead of my x-axis. We can check our points here. This is the point 1/2, 2, so I'm going to do trace with 0.5, and I do get an output of 2. There it is. There's the sweet spot. All right. So pretty good. Let's see. We need to know, how do we generalize all these vertical asymptotes? We've got an asymptote at x equals 0, x equals 1, x equals 2. What are some other asymptotes that we've got?
X equals 3.
X equals 3 and
X equals
4 and 5. Good.
7.
What are those numbers? Integers. So we have x equals k, where k is an integer. And remember, we talked about integers yesterday. What are integers? Not all real numbers. Whole number, negative and positive whole numbers. So that would be like -2, -1, 0, 1, 2, and on and on and on. So really important you know that. Sam. The what symbol?
Like the integer symbol.
I gotta look it up. I don't remember what it is. It's either Q or Z or maybe it's I. I don't know.
There you go.
I'll look it up. I'll look it up when we're done. Maybe I have that book. I didn't burn it in effigy.
Yes.
All right.
Yep.
What's the domain of this function?
No. Everything except
All reals. That's that boldface R, except all that stuff. All reals except those x values that are asymptotes. Yeah.
It's just a bold.
It's a boldface
like
R. Yeah, that's
really long line.
it's like if you
Really
just
thick line.
you do two verticals and then the R. That's the boldface R. That's the mathematical symbol for the real numbers. Yeah. Yeah, I can go to the window. My window went from 0 to 2 on the x, -4 to 4 on the y. It is a 0.5, only because that's what I'm counting by here, 1/2. Yeah. What's the range? Negative infinity to 0. Very good. Right here, we're at this point 0. And then union, it picks back up again at 2 and continues on above. So it's like there's some below and it stops, and then we've got some more that picks back up again. So the range is kind of interesting for these. So in summary, we're drawing our normal sine or cosine curve. Where are the asymptotes?
Every integer.
In general, not just this one. Where do we draw in the asymptotes on our curve? Where it crosses the midline. Where it crosses the midline. And then it's just little parabolas. All right, cool. Let's try the next one. I'm going to do that here because I ran out of space before. So y equals negative secant of 2x plus pi. Which function are we going to graph? Because I don't know secant offhand.
1 over cosine.
Cosine. So we're going to graph cosine by hand. We'll talk about plugging that in our calculator in just a minute. What does this negative do? It's a reflection. Very good. And so this is the reflected cosine song. So that's going to be low, middle, high, middle, low. All right. What's the midline? 0. Okay. So this has a midline at 0. Oh, that's just my x-axis. That's kind of nice. And then what are my max and min values here? 1 and -1, because the amplitude is 1. All right. And then I need to figure out how my horizontal axis goes here. So we're going to take everything with x, and what are the normal starting and ending points for cosine? 0 and 2 pi. So 2x plus pi. So the normal starting and ending points are 0 and 2 pi. I'm going to go ahead and subtract pi. 0 minus pi is negative pi. 2 pi minus 1 pi. And then what do I need to do? Divide by 2. Good. So we get negative pi over 2 and pi over 2, which reminds you of tangent, right? But we're not graphing tangent, we're graphing a cosine curve. So I'm just going to go ahead and I don't really care where we fall in relation to our vertical axis here. All right. What's halfway between negative pi over 2 and pi over 2?
0.
0. What's halfway between negative pi over 2 and 0? Negative pi over 4. And again, that's half of the sum. Negative pi over 2 plus 0. Halfway between negative pi over 2 and 0. Remember that? All right, and between 0 and pi over 2, we get pi over 4. That is supposed to be the cosine curve. It's reflected, so I'm going to draw that in. Low, middle, high, middle, low. Okay, so this is our little cosine curve. He's a little cutie. Okay, and I want to draw some asymptotes. So where should I have those?
At both of the pi over 4s.
Oh, at the pi over 4s that I wrote wrong. Yeah. All right, so again, it crosses the midline at negative pi over 4 and pi over 4. So those are going to be our asymptotes. At negative 1 pi over 4 and 1 pi over 4, where is another asymptote going to be? Three pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4. Is another asymptote. Where's another one? 5 pi over 4. So recognizing those kinds of patterns is a good thing to pick up on. So 3 pi over 4, because we have to be able to describe them. The only reason I'm doing this is because I want my curve to be a little bit longer so I can get one full period. I'm going to flip out my maxes and mins now. So here I have a minimum, and it flips out to these little parabola. Down parabola, up parabola. Down parabola. So here is one full cycle of that cosine curve. It's weird. See, if you only did what we did, you'd sort of be cut off. That is a period. But. All right, so that is secant. And we want to describe these asymptotes. How would we describe our vertical asymptotes? X equals k pi over 4. Very good. Negative 1 pi over 4, 1 pi over 4, 3 pi over 4, 5 pi over 4. So there's some number in front of pi over 4. So k pi's over 4. Where? What is k? Is an odd integer. Good. Because they were odd. Negative 1, negative, positive 1, 3, 5, 7, odd integers. So the domain would be all reals except all of those x's that we just excluded because they're asymptotes. What's the range of this function? Oops. Good. That's a bracket. And then union 1 to infinity? Yes. So I want to check this one in my calculator again, just so we know really how to put this into our calculator. So in my calculator, this is negative 1 times the secant. So that secant, we're going to do 1 over cosine of 2x plus pi. Well, this is -1 times this whole 1 over thing. That'd be -1 times 1. So I can type this in my calculator as -1 over cosine of 2x plus pi. So look for those numbers in front. They get to go in the numerator. All right, -1 over the cosine of 2x plus pi. And I want this window to match the window that I've drawn here, which I'm going from -pi/2 to pi/2. -pi/2 to pi/2 is a great window. The scale is pi/4. And I'm going to hit graph. And I should see my little graph right here between these two values. And I think I do. There it is. Pretty cool. Man, it's like mirror. It's like a copy. It's cool. Okay. All right. And again, I could check values, and that's clearly 0, 1, which 0, 1 we have. So, do you have any questions for me? So, where do you draw the vertical asymptotes? Where it crosses the midline. Where it crosses the midline. And then you just flip it out, right? Because it's a reciprocal. It's just like totally flipped. Yeah, that's the highly mathematical explanation of that. Because it's just flipped.
I like money.
Okay. All right, you guys can work on
Let's do it.
21. Yeah.